Okay, we're live. So I guess we'll just start into part 2. Did you guys open up that SPSS file in part 2?
I haven't yet. I'll do it right now.
Okay. Let me know when you got it up.
Okay. Okay, I got mine up.
Do you have yours, Mackenzie?
Yeah.
Okay, cool. So the first part is, what is a research question, and then state the null and alternative hypothesis. So I guess I'll just read through this first little section it gives us. And it says, a manager at a factory feels that the amount of time that his workers spend during doing their part in assembly line is too long. He measures the amount of time in minutes. 9 of his workers take a complete 100. He measures the amount of time in minutes that 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes that the same 9 workers take to complete 100 products and obtains the following data. He wants to know if the mean assembly time is different and use the level of significance of alpha 0.05. So the first question is, what is the research question?
Is the mean assembly time different?
Yeah, because he's using a new procedure too, so the mean assembly time with the new procedure.
So how you just write that by saying what?
I think you just say he wants to measure the mean assembly time of his
Okay.
new procedure and see if it was different than before.
Okay.
And see if it's different. Okay, so then state the null and the alternative hypothesis. So I think in the section, didn't it say that if you're doing a difference, that the null is always 0?
Yeah, right. That's what he said.
Okay, so
O is U to the D equals 0.
right.
And HA is U to the D and not equal 0. Because
Right.
we're not trying to find less or greater, just different.
Right. Okay. Collect the data. It wasn't super random, but it was just from the 9 workers, right?
Yeah.
So then we go to the analyze, compare means. No.
I think we will do that.
Descriptive.
I think this question is just describe how he collected the data.
Okay. So
I think it's from the 9 workers.
right, and then
How long it took?
Yeah, before and after. Okay. Describe the data. In short, the paragraph uses summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled group to illustrate the data.
so we need the mean of the difference.
Yeah. So you go analyze, and then which one was it? Did you click after analyze? Compare means.
Okay, just a second.
You transform, right? And then compute the variable to get the
Transform, compute, yep. And then we go difference as target variable.
Yeah.
And then we go post minus pre.
Yeah. Post minus pre. Okay.
And okay.
Now we have a new variable.
Okay, and so then we can go
Analyze.
Compare means, or do we go descriptive? Probably descriptive.
I think you'll end up doing both, but I think this one is descriptive.
And then explore.
Yeah.
And then we put the difference on there.
Mm-hmm.
And then you can put, like, you can click on plots and put histogram and normality plots, just if we want a few or a histogram.
Right.
So that
we can look at all that. That's all the descriptive statistics. Yeah, that should be what we need. Okay. Make inferences. What type of hypothesis test is appropriate? Oh, because this one's a two-tailed.
Yeah, the two-sided one.
Yeah. Okay, I was wondering what it was asking. Yeah, two-sided would be perfect. It also says on here, paired sample t-test for means is appropriate.
Okay.
Okay. What are the requirements for this test? They have to be normally distributed and simple.
And a random sample, yeah. Simple random sample and normal. And okay, so we only have an N of 9, so then that's why we need to know what the QQ plot is, right?
Yeah, we're going to have to, because we don't know if... Yeah, and it says right here, continue the test regardless of what you found in part C. So, yeah, so that's why we're computing this. So QQ is in graphs, right? Or no, that's an analyze.
You can analyze and then put plots.
And then we're looking for difference. Okay. Looks not very... It's all right. It's not super straight, but it's kind of in line. Okay. Now it wants us to compute the test statistic. Did you guys get the QQ plot?
Yeah.
Mine is not coming up for some reason.
Mine took a little while to come up too. Like, it was a little bit slow.
I'm gonna do it a different way. It's being really slow. I don't know why mine's not very happy with me right now. Okay, my difference column came up as 0, so I apparently did something wrong.
Okay.
So I gotta go to transform, compute, difference, post, minus. Oh, I put post minus post. Oh.
That would make 0.
Awkward. Okay, minus pre. Okay, that's probably the problem. Okay.
Did you get your QQ plot working?
Let's see if I did. Oh, yep. Okay, I'm on board. I I got the right things going on. Okay, yeah.
Okay, so C.
Pretty close. So.
It's pretty close. So C is t-statistic. So now we're just doing the one-sided mean test or whatever, the 1t, whatever that thing's called.
Right.
In one sample t-test.
And the test value is 0 because that's what our hypothesis is.
Right.
Okay.
So I got negative 1.220.
Right.
And it's also positive 1.220, I guess. D is your degrees of freedom, so that's your n minus 1.
Right.
Which is 8.
8, yep.
Okay.
And then compute your p-value, and that's on your one sample t test. And it's a two-sided, so it's just whatever the p-value is on there.
0.257.
Yep.
Okay.
Make the decision. Do you reject the null or fail to? And we're using alpha 0.05, so I think you fail to reject the null.
Because it's too high.
Yeah, too high. Okay, present your conclusion in the form of a statement. There is insufficient evidence.
Right. We have insufficient evidence to
switch.
Switch.
Yeah, the new assembly is any better. Okay, rather than testing a hypothesis, now say you just wanted to estimate the mean difference between wait times at the 95% level. What would you do? Wouldn't you just...
We just go to...
Don't you just calculate it? Yeah.
Isn't it just the one sample and that gives us a 95%?
Yeah, it should. Even in your...
It should already be on there, right?
Let's go check. So we already had that in our descriptive statistics.
Right, so it's negative 3.051
right.
to 0.9397. So
yeah.
940.
Right. So we could do it just by the formula as well. I mean,
right.
So that's easy enough. Okay.
Okay. Do you remember reading about when it says if 0 is in the confidence interval, then do you remember reading about that? Is it asking us that at all?
I don't think it is asking us that.
Okay.
Okay, 5. In a short paragraph, describe the action you feel to be taken based on the statistics above. Well, don't do what they are doing.
Yeah.
Right.
And figure something else out.
Yeah.
Okay.
Okay, that's good enough. Okie dokie, I guess we can open up the group quiz now. Okay, true. Okay, suppose we have paired sets and let D equal x after and x before. The null hypothesis is the mean equals of D equals 0. The alternative is it does not equal 0, and the standard deviation is not known. Jordan collects a sample size of 9 and computes that what does that D with the bar over it mean? Is that the D
the
mean?
difference
Oh, the
mean.
difference mean. Yeah, difference mean. And the standard deviation, right, that we don't know, equals 3.3.
Okay.
What is the value of the test statistic?
That's 2.2.
Where's our little thing about that? So we go T equals D bar minus O over standard deviation times divided by the square root of n. Is that right?
Yeah, I think that's the one. Is that the one that the book gave us?
Yeah. So it's 2.2 minus the 0. I mean,
Was that in this section or was that in the last section that we got that one?
Well,
this section.
Oh,
I'm trying
I
to see
got
where
this
I
one.
found. Okay, so tell me that formula again one more time.
Okay, it's T equals D bar minus standard deviation. That should be U, not standard deviation. Oh, O means the O in the hypothesis test.
Oh, okay.
Over standard S with the D on the bottom, that means the standard deviation of the difference.
Divided by n, the square root of n.
To the square root of n.
Okay, I need to grab my calculator real quick. Got to grab my calculator. Okay, so how did we set this one up? We have
How I did it? Oh, what is it?
2.2.
How I did it? 2.2 minus 0.
0.
0 is the null hypothesis on all
Right.
these. And then you divide that by 3.3 because that's the standard deviation of the difference, divided by the square root of 9 because that's what we have as a n.
you get 2.
I got 2.
2.2.
So that's the answer.
Yeah, I guess that's what the test statistic is. That's what T equals is 2. So that's what it would be.
2. Yep.
Is that what you got?
Yep.
Okay.
Do you put 2.0?
May as well.
Okay. The probability of being greater than 2.0 is 0.0403. Use your alternative hypothesis to determine the p-value.
Okay, so how do we do that?
Probability of being greater than 2.20. Isn't it 0.0403?
To determine the p-value for this test.
Because using the alternative hypothesis, we wouldn't divide it by 2. It would just be...
Yeah, it would just be that same thing, right?
Yeah, right.
They just gave it to us. The probability is that, and then the alternative hypothesis
would mean it's a two-tailed test, so it's that. That's what I think. Yeah, I don't know. Do you know another way that we could compute it?
Well, we get the p-values usually by using the little applet things.
Right. And we do have an applet. I mean, but it's a t-score applet, and they said that you can't use the t-score applet to find probability of a t-score.
Probability of being greater than 2 is 0.403. Use the alternative to determine the p-value for this test. Well, that would probably be it because the HO of the thing would be 0, and the alternative is what we're trying to figure out what it is, and so it would be O4O.
Yeah.
O4O, right?
Yeah, O4O.
Okay. I think that has to probably be right.
Yeah. Okay. Use the data file, chapter 12. Okay, we gotta go open that. And then we'll use SPSS. Is it chapter 12A? Is that what it is? Yeah, chapter 12A.
All right. How am I going to get to that and get out of this?
Okay.
Are you just opening up another DIL, or are you saving your test?
Yeah, I'm just opening up another one. Chapter 12 data A. And it's asking us to basically do what we did on the...
And you're getting that out of our lesson?
No, I went to data files. So if you go up to the top where the lesson was, to the left, it says main page, schedule, data files, exam review. And I click data files.
Wait, what? Where is that at?
So like go to your book.
Okay. Okay, got it.
That's up to the left. And then if you scroll down, there's a chapter 12 data A.
Mm-hmm.
To your left. I don't see up to your left.
So at the very top of the page, there's a BYU Idaho symbol.
Okay.
Do you see that?
Oh, data files. Yep, I see it.
Yeah.
And then we just go to SPSS and it's just data files?
It's no, it's chapter 12 data A is the file.
Data A. Okay. Good thing you're paying attention. Okay. Got it.
Okay, so then we're going to compute the difference statistic in this one. So transform, compute statistic again. Then group 2 minus group 1. Is it group 2 minus group 1?
Yeah, it always is. Yeah.
Okay. Okay. Did everybody get that?
1 sec. Okay. So I put it in group 2 minus group 1, but then it says that it contains an illegal character.
Oh, did you put a thing on the difference thing?
No. Maybe I did. Maybe I put a space after it. Okay. You did.
Okay. You get it?
Yes, I put okay, but nothing's coming up. Okay, you got it.
Okay, and then we'll do analyze and descriptive statistics to find the difference in the standard deviation.
Right.
Okay, I got my mean to be negative. Is that what you guys got?
Let's see what it comes in. My mean is negative 31.025.
Yeah, that's what I got too. My standard deviation is 341.
Yeah.
That's a huge standard deviation.
Yeah.
157.
31.025 is the mean. And standard deviation is 341.157.
Yeah, right.
I didn't even see if that's where we're... Are we putting that on the test yet?
Yeah, that's number 5 and number 6.
Okay, I got to get back to my test. Where am I at? Okay. Okay, number 5 is negative 31.025. And then 6 is 341.157. Okay. The test statistic is, we have to go to analyze,
compare means.
One sample, difference.
So
Okay.
mine
is negative 0.47.
Yeah, negative 0.47.
Is it 407?
407, yeah.
Okay.
What is the p-value? So this is an open, so the p-value is 0.689.
Yes.
So what is the correct decision? So our level of significance in this one is actually 0.10. So we would actually fail to reject the null.
Does it say our level? Oh, it is. It's 0.10. So that's 2.
So I still think that our number is still too high for that because it's 0.6 instead of 0.1.
Okay, so fail to reject. You're right.
Yeah. Suppose that your alternative hypothesis was the correct decision based on the evidence. Then what? Reject the null?
Yeah, then we would, well, it's
Suppose
different.
that it's greater than 0, right? Is that what it's saying? Or
Yeah, if your mean was greater than 0, so you would reject the null, right?
Yeah, because we're trying to, the null would mean it was
the same.
Right.
Yeah. Okay. And we're doing it again with chapter 12 data B file. So.
Okay.
so. Okay.
I would just exit that one.
Okay, you think we can be done with this?
Yeah. There you go. Okay. So we're doing the same thing. Transform, compute. It's group 2 minus group 1.
Yep.
Okay, so 11 is, which is greater? N or your degrees of freedom?
Well, N, right? Because.
Yeah, because your degrees of freedom is N minus 1.
Yeah.
Yep.
That's a weird question.
That is a weird question.
Your alternative hypothesis does not equal 0. Use a level of significance of 0.01. What is the p-value? Okay, so we're going to analyze, compare means. Okay, so I got a p-value of 0.001.
Right, and it's one-sided, so no, it's not one-sided. They're
Not
asking.
one-sided, yeah.
Okay.
Okay, based on this decision, do you fail to reject or reject? What? It's less than 1, so you would reject the null, right? So you guys got 2?
Yeah, reject the no, because that's less.
And we typed in 0.001 for number 12, right?
Yeah.
Yeah.
0.001. You decide to try another alternative hypothesis. This time you use the difference mean is greater than 0, and you keep the same level of significance. Based on this p-value, increase or decrease? Oh, so the last one, I think when it was asking us, suppose your alternative hypothesis is a number 10, I think we have to divide our p-value in half.
And what was our p-value? Okay, p-value is
0.689. So the p-value would be 0. You'd still reject the null or fail to reject the null.
So it's failed.
It is still too high.
Yeah, it's still too high in 10.
Okay. So that's why it was asked. That's how.
Yeah, that makes sense. Okay. This time you use, so you're doing the same thing. So it'll be 0.001 divided by 2. And it says, does your p-value increase or decrease? It for sure decreases. And you still reject the null.
Because it's lower.
Fail to reject or reject?
You reject.
Because it makes it even lower, and that's why.
It's still. And it was already lower before. Okay. As we have seen, the p-value depends on the alternative hypothesis. Setting aside the data in this problem, do you think that the general rule can be made which alternative hypothesis will give you the smallest p-value?
Will give you the smallest p-value?
Well, a two-sided tail is going to give you the same.
Right, and then the other two will be equal.
Right.
Because if it's greater or less, you still only use half, right?
Right. Either way, it doesn't matter which side it is. Do you think a general rule can be made?
Well, setting aside, do you think a general rule can be made? Well, usually when you divide it in half, it'll be the smallest p-value, but...
They would both make a small p-value.
Yeah, so I don't know.
In this one, they made us say that the mean difference is greater than 0 on both of them, and it made a smaller p-value in both cases. But it would make a smaller p-value even if it was the mean difference was less than 0.
Yeah.
I don't know about that one.
But if you say not enough information, it depends on the problem.
That's true. Because what if your p-value was like 0?
Yeah.
So then we would be saying that we don't think a general rule can be made.
I don't know. I guess go with whatever you want on that one.
Okay.
Okay. But we can determine the 95th percentile confidence interval.
Yes.
So that is descriptive explore.
So that would be negative 186.1.
The lower bound, yeah, negative 186.007. Wouldn't it be negative 18.607?
8.607, and then the upper one would be
negative
5.303.
303, yeah, negative 5.303.
So, did you guys put not enough information for number 16?
I haven't put anything yet. I don't know what to put.
I just put the one that says it's less than 0, like that would give you the smallest p-value, because like if you divide that in half as opposed to something greater than 0, the less than 0 is going to be smaller.
But it's the same number.
It will always be the same number, even.
The p-value is the same number, and you divide it in half on
Yeah.
both cases. So I don't know if it. I think I'm just going to put it depends on the problem, but I don't know if that's really the case because it doesn't, because it's always going to be divided. So I think it might be one of the less or greater than ones.
Well, we use greater than in both of the situations here, so I might as well just go with greater than. That's what I'm gonna do.
Or what are you going to do, Ken? Go less than?
Well, that's what I was thinking, but
Yeah, I guess if we all do a different one, then we'll know who's right in the end.
Setting aside the data, do you think a general can be made? I don't know. That's a real bummer.
Yeah.
Yeah.
All right. How do you guys feel about all of these? Okay.
Yeah, I'm gonna submit it.
Okay.
Okay, it's not enough information. We knew it, dang it, we knew it.
Oh, I put that one.
You did? Yeah.
Yeah, I just was like, I just don't know.
Right, and then we didn't do 4 right. I don't know what we did wrong there.
Yeah.
I don't know how to do that one.
I know that was weird.
Yeah.
Probability is that. Maybe there's a little thing we're supposed to use, a little.
I'll send the teacher an email and ask him see if he'll explain that.
Yeah.
Yeah, is there? Can you think of a p-value equation that we have that we could have used?
I don't think so, but I'll ask him, and then I'll send you guys the email.
Okay, well, yeah,
Good
that
job,
was
guys.
kind of a weird one in the first place. So.
Well, good job. I'll post the video.
Thank you.
Yep. See ya.